Hello Math 30-1 and welcome to your 5th lesson on functions. In today's lesson, we're going to be looking at the composition of functions, which means like a function of a function. Doesn't quite mean multiplication, it's putting one function into another. So if we remember back to Math 10 when we did substitution, remember when we did systems of equations, there was substitution and elimination? We did substitution. That is kind of like composition of functions. Also, you do it sometimes in physics when you want to isolate or get rid of a variable. Here's an example here. We have this Toyota Camry. It's a 2012, a 3.5 liter V6, okay? We know approximately an 8.2 liters takes it 100 kilometers. The cost of gasoline is 1.25 liters per kilometer. So here we want to know per liter. So how a liter, like how far does it go per liter? So it goes 0 point, if I look at this here, I want to go 8.2, I want to know the function of distance per liter. 8.2 divided by 100. So I end up getting 0.082, okay? Because that's my distance, okay? There we go. So each distance is only 0.82 liters. So I have to multiply this by my distance to get how many liters we go, okay? So that's how many liters we go per kilometer. So it's 0.0082 per kilometer. So now it's in terms of distance. Now let's take a look at the next one. We want the terms of cost. Well, that is $1.25 per liter, okay? So here, let's add this together. Now we want to know what is the cost per kilometer, or the distance. How can I make this for distance? Well, we want to know, so for distance. So we have here, I know 1.25 liters is going to give me my cost, but I need this to be in terms of distance. So that's the same as 1.25, and I know L is 0.082. Okay? Now I combine this together, multiply that together, and that's in terms of distance, we get 0.1025 distance. So I multiply how many kilometers by 0.1025, and that's going to give me my price per kilometer, okay? There we go. Does that help? So pretty much I know my liters per kilometer, and I know my dollars per liter. By combining those, putting one of a function of another, right? I use substitution into the formulas. I was able to figure out my cost per kilometer. All right, so here we go. Let's start off here, and it says consider the composite function. I have x squared minus 2. How does this work? So describe in words the order which we apply it. Well, the first thing I do here is, remember bed mass? I square x. So first, square x. Then, what are we going to do? Then, I subtract 2. Now, let's take a look at this here. Part B, we want to know what's happened. So when x went through f first. So what did we do? We squared it. We end up with x squared. Then we went with the function g of x, which is function g meant we subtract 2. So that's x squared subtract 2. So what is the function f of x? That is x squared. Where's the function of gx squared? That is x squared subtract 2. Now what happens if we just did g of x with x and we didn't do that? That is just x subtract 2. Okay? Hopefully you get that. We'll do a couple more and it'll get a little bit easier for you. So let's take a look at the next one. It's a bit different. Put it in words. Now we look at bed mass, brackets first. So we do what's in the brackets first. So first we add 4. Then 4 to x. Then we cube. Okay? So, first thing we do, f of x is x plus 4. So we add 4. Okay, so we get x plus 4. Then g of x, the second function, says we cube it, which is x plus 4 cubed. So what is the function f of x? Well, it's just x plus 4. What is g? X plus 4 is x plus 4 cubed. Now what if we just did g of x, just the function g of x? It's just cubing x. That's it. We're just cubing it. That's it, or x cubed. Alright? But we did f of x first, so we put f of x into g of x, and that's what we get. We'll do a little bit more and you'll get a little bit better at it. So, let's take a look at these here now. It says, composition of functions. So first we start with this, then we replace f of x with that formula, and so on. So let's start here. Given f of x is 10x plus 1 and g of x is 2x minus 5, complete the work before when we say g of f of x. Okay? So we're starting with, this dot does not mean multiplication. Key thing, it does not mean multiplication. It means the function of f of x. So we're going to start with g of f of x. Okay? Now, replace f of x with the formula of that, because we know what f of x is, so it's a substitution. So now it's g 10x plus 1. Okay? Now, we're going to apply this to formula g. It's kind of like what we were doing in these loop things up here. So we're applying this into formula g. So all of this replaces every x in g now. So we end up getting 2 10x plus 1, and then we're going to subtract 5. Okay? Now write the simplified equation. We get 20x plus 2 subtract 5 is minus 3. That's it. So we go 2 times this, 2 times that, subtract 5. Now, let's take a look at the second one. It says, if 2x squared minus 1 is equal to f of x, and we have g of x is equal to that, find g f of x. So we're going to have to put in f of x and for g. So g 2x squared minus 1. So we want that as that function. Now what is, we're putting this for every x. So we have 3, 2x squared, subtract 1, and then we subtract 4. Alright? Continue this out. This gives me 6x squared minus 3, and then subtract 4 is minus 7. So I end up with 6x squared, subtract 7. Okay? That's my answer. Let's try the next one. We want g of g. So that is g of, what is g? 3x minus 4. This is going to give me something very interesting, I believe. Well, let's take a look at this here. I end up getting 3, 3x, subtract 4, minus 4. Okay? So, what's 3 times 3 is 9. So that's 9x minus 12. And then I'm going to subtract 4, which ends up giving me 9x subtract 16. That's my answer for that one. So now we're going to get into a bit of domain and range. I'm just going to start you off with this. So first, without finding the formula, evaluate each of the following. Okay? So we want f of g. So we're going to put in for, we want f of, so first I'm going to put g of 2. Okay? So we want f g of 2. Okay? So that's going to give me the same thing as f of, well, what is the 2 for g? We have to put in the 2 for g, so that's going to be square root 2 minus 1, which is the same thing as 1. Okay? So now we're putting this in for everything in f. So we get 2 minus 1, square root of 2 minus 1, squared minus 3. So that gives me 1 subtract 3, which is equal to negative 2. Alright? Kind of ran out of room there. Now let's try the next one if we're putting in 0. So we have f of g of 0. So that is the same as f, and we put 0 in. That is negative 1. Square root of negative 1. Now, if I look at this, can you square root a negative number? No, so there is no solution. This does not exist. Let's try g of f of 2. Okay? So we want g of f of 2. So g f 2. So we want f2 first, so we want g of, put in 2, so it's going to be 4 minus 3. Now I put that in, I'm going to get g is going to be, we have 4 minus 3, which is 1. So I'm going to have square root of 1 subtract 1, which gives me 0. Alright? Let's take a look at the next one. We want 0. So let's try this. We want g f of 0. Okay? So we have a look. We put in 0 for x squared. So it's going to be 0 squared minus 3. That's g, which gives me the same as negative 3. So that is negative 3 square root subtract 1. That gives me square root of negative 4. So there is no answer. Now, based on this, this one doesn't work, this one doesn't work. So can we state the domain of f and g? Well, the domains, what can x equal to? For f, here, f could be x is an element of all real numbers. X is an element of all real numbers. Okay? For g of x, we have x such that, now x must be greater than or equal to 1. Okay? And x is an element of all real numbers. Alright, now we want to look at the ranges. Okay? So here, we're looking at y. So for y, we have y such that y must be greater than or equal to, and in this case, negative 3. Okay? And y is an element of all real numbers. And here we're going to look at x such that, or y, g of x, we're going to look at y such that y must be, in this case, greater than or equal to 0. And y is an element of all real numbers. Alright? So that's just by looking at it. Now, here we have Aaron. In order to determine, Aaron found the expressions of each one, and he used the graphing calculator to graph the composite functions. He attained the following graphs. Okay? So here's his domain, and here's his range. Now it says, find the expression. There are errors in Aaron's thinking. So he's... Sorry about the announcements. So we come back here. So there's an error in his equations. He's looking at it, but it's not looking at everything. He combined them, and it's actually a little bit different. So we're going to look at this here. So we have f of g of x. Okay, we're going to look at this one first. So first of all, we're going to put the equation in an equation. So I'm going to end up getting, where's f of x? So we have f, and then g of x is the same as square root. We want x subtract 1. Okay? Which is the same thing as 3, or sorry, we want it squared, x subtract 1, squared, and then we're going to subtract 3. There we go. Sorry again for the interruption. So now if I do this, this ends up giving me x subtract 1 minus 3, which is equal to x subtract 4. So that is why when we graph this, he gets a graph like that, and it shows that everything is in there. So we said x is an element of all real numbers. But, in fact, we have this g of x function there, don't we? So really, x must be greater than or equal to 1. So that is really what my range is. x really must be greater than or equal to 1 on that thing there because of this fact section there. I can't square root and square if I have if x is anything less than 1. Okay? So let's take a look at my next one here. We want f or g f of x. Okay? So we're going to continue that. We have g, and we're going to be left with x squared, and I think that was minus 3, which is equal to, put this in here, we have g, and we have, oops, put that in for g, so we have square root, x squared minus 1, subtract, or minus 3, subtract 1, which ends up giving us x squared, square root, subtract 4. Alright? Now I look at this here, I have two possible solutions. Now, this can't be a negative, so I have x squared has to be, or x, because it could be positive or negative, x has to be greater than, or less than, or equal to negative 2, or we could have x must be greater than or equal to 2. Okay? So those are the two things we could have there. Because once I get a negative number, if I put in negative 2 or greater there, it ends up working. Okay? And if I put in negative 2, and if I put in 2 or greater, it works. I just can't have that in between where the squared number is less than 4. Okay? So that is my solution for my domain there. So now if I look at this at the final step here, we want the domain of f of g. Okay? So for this one here, my domain cannot be more than g. Alright? So my domain here is we have x such that we have x must be greater than or equal to 1, and x is an element of all real numbers. Okay? So this one here is g. Domain cannot be greater than g, and the range cannot be greater than f. Okay? So my range cannot be greater than the range of f, which is, we go back up here, we use my range of f that was discovered before. So my range is going to be y such that y is greater than or equal to negative 3, and y is an element of all real numbers. Okay? Now let's take a look at this one. My domain can't be greater than this f. So it's the inside one. Domain can't be greater than the inside one. Range can't be greater than the outside one. Okay? So domain can't be greater than that one. So in this case, my domain is going to be what we found out before in here. So I put that in. We end up getting x, well, we're looking at x such that x we have is negative 2, and we have x 2. All right? And now it cannot be greater than this. So it can't have more than my domain here, which makes sense. Now my range can't have more than that g. So my restriction on g is right there, and it cannot have more, so I'm going to have y is greater than or equal to 0. Where y is an element of all real numbers. Okay? So a little sum up of that, if you're a little bit confused, is you just read this here and go over the domain and ranges and how they work in most cases. Hopefully you understand that a bit. If you need more clarification, you talk to me tomorrow about this as we work on this together as a class.